Hello, mathematicians. This is lesson 5.4. In this lesson, mathematicians will examine the relationship between sine and cosine with complementary angles. So, if you missed class, we worked on checkpoint 4. And at the start, students with last names A through L solved for X, Y, and Z in column A, and students with last names M through Z solved in column B. Try your best to solve one column for X, Y, and Z, and pause the video. Now you're back. Students came back and shared their answers, and what we noticed was that students in both column A and column B got the same side lengths. 9.28 for the first one, 5.44 for the second, and 10.44 for the third. But the angles were different, and they were solving for different sides. So why did both columns get the same answer, even though they used different trigonometric ratios? For example, in this case, adjacent over hypotenuse, they used cosine. But in this case, opposite over hypotenuse, they used sine. Same for the second one. In this case, opposite over hypotenuse, they use sine, and in this one, they use cosine. So we took a look at the angles in each of these triangles. In the first one, the two angles were 41 and 49. The second, 65 and 25, and 50 and 40. What do we notice about the angles of these triangles? Well, we noticed that all of them added up to 90. These two angles were complementary angles. Two angles that add to 90, or the two acute angles in a right triangle. So going back, in this triangle, the other angle of the triangle, in order for all angles to add to 180, must have been 49. The complement. In this triangle, the other angle, the acute angle here, would have been 41, making these two triangles the same. So we know that the sine of 49 was the same as the cosine of 41. The cosine of 25 was the same as the sine of 65. And that's because the sine of one angle is equal to the cosine of the complement. For example, sine of 65 is equal to the cosine of 25 because 65 and 25 are complementary angles that add up to 90. Why do we need to know about the sine and cosine of complementary angles? Well, it allows us to solve for missing sides in more than one way. For example, which trig equation would we use to solve for AB? AB is the hypotenuse, and we have the opposite, so we would use sine, opposite over hypotenuse. But can we use another reference angle besides 25 degrees? Yeah. We could use the angle here, 65 degrees. And in that instance, we would use the adjacent side and the hypotenuse. Cosine of 65 equals 2 over x. So we learned that the sine of one acute angle equals the cosine of the other acute angle in the triangle, or the cosine of the complement. All right, now you're ready to go on checkpoint 4. Thanks for listening.